In this video, I am going to start to talk about some circuits. So really there are two different ways in which you can set up a circuit to achieve sort of two opposite goals. The first type of circuit that we can set up is a series circuit. And a series circuit is one with only one path for the current to follow. So there's only one path for the current to follow. And because of this, the resistance increases and the current then decreases. So the whole point of a series circuit is to affect how much current that you can get somewhere and to actually decrease the current, okay? Now most electronic instruments are set up so that there's an optimal amount of current that flows through them so that they function properly. They're at the right temperature, they're emitting the right amount of power, okay? So a series circuit is drawn like this, okay? So again, you have two resistors or multiple resistors, however many, in series with one another. And so the current only has one path to follow. Now, in this case, the resistance is calculated by adding the sum of all the resistors. So if this is resistor 1 and this is resistor 2, then resistor 1 plus resistor 2 plus however many resistors that you might have, in this case we only have 2, would be equal to the total resistance of the whole circuit. This is also sometimes called equivalent resistance, okay? But those are the same thing, all right? Now, because there's only one path for the current to follow, the current going through every single resistor is going to be exactly the same and equivalent to the total current in the circuit, okay? And then the last factor that's here is the voltage, right? So because the two resistors are in series with one another, they actually sort of have to share the voltage of the battery. So voltage 1 plus voltage 2 plus however many resistors you have is going to be equal to the total voltage of the battery, okay? So when we solve for a series circuit, let's just say our resistors in this case are 3 ohms. So this one's 3 ohms and this one's 3 ohms, okay? Whenever you're solving a circuit, the first thing that you do is you find the total resistance, right? And let's say this is 9 volts, okay? So the total resistance would be 3 ohms plus 3 ohms would give you a total of 6 ohms, okay? Then you want to find, well, what's the total current? And for this case, the total current is equivalent to the current at any point in the circuit. So we're just going to use V equals IR, and we'll take the volts divided by the resistance, so divide by resistance, and that will give us current. So 9 volts over 6 ohms, and that should be 1.5 amps. Okay? Now, because we know that the voltage needs to be shared, and because the series circuits are both 3 ohms, they're going to share evenly, right? But we could calculate, and so we know they should each have 4.5 ohms, but we can calculate that mathematically by just using V equals IR again, where the voltage at each resistor is equal to the current at that resistor times the resistance of that resistor. So it would be 1.5 times 3 for each of them, so each one would get 4.5 volts, which would then be equivalent to 9. Right? Now let's look at it in the case of a circuit that has different resistors, right? So let's say instead of having a 2 ohm or a 3 ohm and a 3 ohm, let's say you have a 3 ohm and a 6 ohm, okay? Again, the first step to any circuit is to calculate the total resistance. So 3 ohms plus 6 ohms is equal to 9 ohms, okay? Then I'm going to find the total current, because that's the current everywhere in the circuit. So I just take my volts and divide them by my ohms. And so in this case, there's only 1 amp of current moving through the circuit. So by adding a higher resistor, we're slowing down the resistance. Okay. Then if we want to know the voltage at each one, then we just would multiply the current, which is 1, times the resistor. So 3, and then you would have V equals 1 times 6. So here, there would be 3 volts and 6 volts, which would be a total of 9 volts. Okay? So that's some very simple series math. In the next video, we'll look at how we can build circuits so that we decrease resistance and therefore increase current.